Hi, everyone, and welcome to Cognify. So, in today's session, we'll be tackling a few questions, right? Touching on a few physics concepts in mechanics. So, let's look at the given scenario here, right? So, we've got a learner and her family that live on a hill, and they are remodeling their house. So, they've hired a rubbish skip to hold the building rubble. So, this skip weighs about 320 degrees and it is placed on a hill, right? So you can see here that it's on an inclined plane. So this inclined plane is 15 degrees relative to the horizontal. So let's go to our first question. So in the first question, we want to define frictional force. What is frictional force? Okay. So frictional force is a contact force. Okay. And this contact force occurs between two surfaces. And those two surfaces have to be in contact. So as you can see here in this example here, we've got a skip which is on a plane, okay? Since it's on a plane, it is in contact with that plane. The plane will serve as one surface and the skip will serve as the other surface. So these two surfaces in contact, what happens between the two? There is a frictional force acting between the two, right? Restricting the motion of our object. And that is basically what a frictional force is. It is a force that opposes motion, right? So you can say it opposes motion. So I'm just putting some main points here, but I'll leave it to you as the viewer to take all of this and construct it as a definition. So frictional force opposes the motion of the object. Okay. So in a nutshell, that's basically what a frictional force is. So it's a contact force that develops between two surfaces that are in contact. Now let us go to the next question. So in question 3.2, we want to calculate the force of static friction exerted on the skip. But before we go ahead and do it, I just firstly want to differentiate between the types of frictional forces, right? Because there is static friction, which applies to this scenario we have here, right? Where we have our object which is in contact with the surface, but that object is not moving. Okay. So static friction only applies to cases where our object is not moving. And another case, okay, is when our object is moving. Okay. So we need to differentiate between the two, static friction and kinetic friction. So now let us go ahead and answer the second question by first drawing a free body diagram. And I advise you to always construct a free body diagram anytime you're dealing with these type of questions, right? Where you've got different forces acting on an object. So a free body diagram will give you like a high level overview of the types of forces that are acting on the object. Okay. So let us go ahead and draw it here. So there are several forces acting on this object, right? One of them is the force of gravity acting downwards. Okay, so this is FG. And note that our object is on a plane. So let me quickly, I'll just put a plane here. Uh, so this will serve as our plane. Okay, so now we've got FG, which is acting vertically downwards, right? Which is the case when it comes to the force of gravity. Okay, however, one thing that we need to keep in mind is that an object that is placed on an inclined plane, the force of gravity acting on that object can be broken down into its components. So there are two components here, right? The perpendicular component, so this one here is perpendicular to the surface, so it acts in that direction, okay? Perpendicular to the plane. So that will be FG perpendicular. And now another component of gravity is the parallel component, which is parallel to the surface. So it's going to be in that direction. And we'll call that FG parallel. And then lastly, we've got the normal force, which is perpendicular to the surface, acting upright. Okay, so this would be FG, not FG, but we can call it as FN, okay, or simply N for normal. So what you need to keep in mind is that the normal force and the force of gravity, the perpendicular component, right? Their magnitudes are the same. So now we have our free body diagram, okay? And now we want to find our static friction. So now let's see here, right? Static friction, which is defined as Fs, okay, is equal to Fg times sine of theta, okay? Why? Because the object, right, which is on a plane, there's a force being acted on it, which is restricting it from moving. That is the static friction, okay? And that frictional force here is going to be acting in this direction here, okay, up the plane. So now, in order to find it, we first need to compute this, okay? But Fg sine theta, what does that mean? Okay, remember that we had broken down our gravitational force, right? The force of gravity into two components, the perpendicular and the parallel. So now from the free body diagram that we had constructed, which of the force of gravity, which of its components can we utilize? Okay, so it will have to be Fg parallel because it's acting along the plane. So we can be more explicit here, right? And write Fg parallel times sine of theta. Okay, so now before I go further, right, I just want to spend a minute just explaining why we are using sine of theta instead of cos of theta for those that are not too familiar on this. So if we refer back to our free body diagram here, right, let's firstly and see if we can put a, I'll just put it down here, right? So I'm going to put that horizontal plane, right? So I'll represent it with a dotted line for now, okay? So there's this angle 15 degrees here, right? The angle that was given. That angle, we can actually put it up here, okay, between the perpendicular component. We just put it here, 15 degrees. So this angle is between the perpendicular component and the actual component of the gravity, okay, Fg. Because you remember Fg, we had broken it down into Fg parallel and Fg perpendicular. So this angle that we're putting here is between the perpendicular and the Fg that is acting strictly downwards. So now if you look here, right, note that Fg parallel, it also applies here, right? If we draw another dotted line here, this dotted line and this plane are parallel, okay? So now let's take this part here. Okay, I'm going to redraw this part, this triangle here, right? So let's take that and draw it here. Remember, we have our FG perpendicular, and then this is our FG parallel. So just to not confuse you guys, right? It's this one here, FG parallel on the plane. I'm just putting it down here for the purpose of illustrating how we basically get to sine of theta, right? So we've got our 15 degrees here, okay? So now you can clearly see that FG is opposite to our angle, okay? It's opposite, and our hypotenuse will be f of g, okay? So now f FG parallel divided by f of g is equal to sine of theta. Okay, because here, according to relative to our angle, right, we have opposite, which applies to FG parallel, and hypotenuse, which applies to f of g. Okay, so now that's how we're able to derive sine of theta. And if you were to find FG perpendicular, you would use cos of theta instead. Okay, but anyways, let's continue. So now this is our formula for static friction: FG parallel times sine of theta. So now FG, let me just fix something here. There we go. Okay. So our static frictional force, right, is equal to Fg sine of theta. And note that this part here, Fg sine of theta, this is Fg parallel. Okay. So now let us plug in our values and see what answer we get. So f of g is equal to m multiplied by g. And now our given mass is 320 kilograms. And the force of, not the force, but the acceleration due to gravity is 9.8. And sine of 50 degrees. And now once you plug this into your calculator, you'll get an answer of 811.66 newtons. But we don't end there, right? Frictional force is a vector quantity, which means when you get an answer, you specify the quantity, okay, the magnitude, which is 811.66 newtons, and you also specify the direction. So is this force being applied up the scope or up the slope or down the slope? Okay, so if we go back to our free body diagram here, okay, one thing that I did not include, okay, was the component for friction. I'll just add it here. So it's going to be in that direction. Okay, and keep note here, right, that this object is not moving, it's stationary, right? So the force of gravity parallel to the component and the frictional force right on the plane, their magnitudes are equal. Okay, the only difference is the direction. So FG parallel acts down the plane and our frictional force acts up the plane. So now we specified 811.66 newtons, and then we indicate is it up the plane or down the plane. So we'll say it's up the slope. Okay, and you can also, when you're doing calculations, right, you can set your direction. You can say we choose up the plane to be positive and down the plane to be negative. So if you are asked to find the force, some other force acting in a different direction, right, you get that answer and then specify it's down the plane. And that is basically it for that question. So now let us go to the next part. So in the next question, we now want to find the coefficient of friction between the skip and the road. So in order to find that, okay, we first need to define our formula. Okay, so now let's see here. So if we go back to our free body diagram, okay, and check here. So we want to find the coefficient of static friction. Okay, and that static friction, what is it dependent on? It's dependent on the normal force. Okay, so now let us quickly define our formula here. So what we want to find is this coefficient, right? Mu, which is equal to Fs, which is the frictional force, divided by the normal force. Okay. So now the frictional force, we already have it, right? It's 811.66 newtons, but we don't know what the normal force is. Okay. So if we check here, if you can recall that the normal force and the force of gravity perpendicular to the plane, they are equal in magnitude but opposite in direction. Okay. So I'll just note that down here that the normal force is equal to Fg perpendicular. Okay. So now what is Fg perpendicular? So Fg perpendicular, okay, is equal to force of gravity multiplied by cosine of theta. So remember what we did here previously, right? Where we found Fg parallel to the plane. We use sine of theta instead of cos of theta. So when finding Fg perpendicular, you'll be using cos of theta. So now our answer here, okay, once we plug in the values, let's see, it's going to be 320 kilograms multiplied by 9.8, which is acceleration due to gravity, multiplied by cos of 15 degrees. Okay, so now the answer you'll get here is 3029 newtons, 3029,14 newtons. Okay, so that is our force perpendicular to the plane. And given that the normal force is equal to Fg perpendicular, okay, it's just acting in opposing directions, we can use this magnitude here, okay? So this is equal to negative n. So now if we plug it here, and don't mind the signs for now, right? Because the coefficient is not a vector quantity. So now Fs is equal to 811.66 newtons divided by 3029,14. So now once you plug this into your calculator, you should get an answer of 0.268, or you can round it off to 2 decimal places. And that is basically it. And the coefficient doesn't have units, okay? So now let us quickly reiterate what we went through, right? In this video, we covered defining frictional force, which is a contact force acting between two surfaces, right? So it opposes motion. And in the next question, we calculated the force of static friction, which is acting on the object. And note that this only applies to cases where the object is not moving. And then lastly, we had calculated the coefficient of friction between the skip and the cloud. I hope this video was beneficial to you. If it was, please like, subscribe, and share. Thank you, and till next time.